In order to make a home as energy efficient and comfortable as possible, architects and contractors minimize the three properties of heat transfer: conduction, convection, and radiation. We will explore one of these three forms, radiation, and investigate how it is experienced within an affordable housing project. In a building, the most significant example of radiation is the transfer of heat energy from the sun. The space between the sun and the earth contains a vacuum. There are no solids or fluids between the sun and the earth's atmosphere that would enable conduction and convection to transfer the heat. Radiation is the only way that heat can be transferred from the sun to our planet and our homes. Every object is constantly absorbing and emitting radiation, but we do not usually notice it until the object is hot. Many of the design elements of a building play an important role in the transfer of heat from the sun.
When the sun heats a building, that heat is going to be transferred throughout the wood and the insulation and all the different layers of what they call the envelope of the building.
Reducing the effect of radiation on a surface, such as a roof, can be as simple as changing its color.
Radiation from the sun hits the roof. When it's a black roof, there's a portion of it reflected, but it's very little, and the amount of heat that gets conducted into the building is much higher. Whereas when you have a white roof, a lot of the heat is reflected back, and then that portion of the heat that gets conducted into the building is much less.
To reduce energy costs in this building, photovoltaic or PV roof panels are used to generate electricity. As well as producing electricity, they also serve another function.
So many people think that solar panels only absorb the radiation of the sun to produce electricity, but they also create shade on the roofs of the buildings, which decreases the amount of radiation and heat that gets conducted into the building.
When you're designing and when you're building a building, you have to pay attention to the properties of all the different materials. Some of them have to hold the building up, some of them have to keep the wind or the rain out, or keep the indoor air in. All of the process of building a building, you have to pay attention to what all those different trade-offs are.
Many compromises are made in the design of an energy-efficient building. This is particularly evident in the windows of a house.
With radiation transfer, the biggest component would be solar heat gain through windows.
In order to reduce radiation transfer through the glass, what we do is we add a low E coating. The low E stands for low emissivity.
Emissivity refers to the ability of a surface to absorb or reflect heat. Low emissivity glass is a poor absorber of heat.
It's a thin metallic coating. It's so thin you really can't see it. You can actually look through the window and see outdoors, but that coating reduces the radiative coupling between the inner pane of glass and the outer pane of glass. And so that actually improves the thermal performance because you're cutting down on that radiative heat transfer. It also cuts down on the solar radiation entering into the building, which really helps on reducing the air conditioning loads in the summer.
Daylight that comes through windows can offset the need for artificial lighting and also provides a psychologically healthy connection to the outdoors. However, solar heat gain from window glass is often the reason many buildings require air conditioning.
This number over here is solar heat gain coefficient. That basically tells you how much of the solar radiation that's hitting this window gets in. The low solar heat gain coefficient cuts down on solar gain when you don't want it, which is in the summertime when you're air conditioning. So on the south and on the east and the west sides of the building in particular, where you get most of that solar gain in the summertime, this low solar heat gain coefficient will really help reduce the air conditioning loads.
There are other ways to minimize the amount of solar heat gain radiated through windows.
We also have shading overhangs built into the exterior of the building to provide approximately 50% of shading during the overheated periods of the summer.
Other forms of radiation play an important role in the transfer of energy into or out of a home.
I'm sure most of us have been in those older buildings where you've got those old cast iron steam radiators, and those get really hot. You do feel much more of the effects of radiation, and you walk into a room and you feel that heat source. Today's baseboards don't operate at quite the same high temperature, and there's the other convection heat transfer mechanism that is working with those.
Many modern radiant heating systems supply heat directly to the floor or to panels in the walls or ceilings of a house. These systems deliver heat directly from a hot surface to the room. This form of heating can be more efficient than forced air systems because less energy is wasted as heated air travels through ducts. Controlling the effects of radiation, in addition to those of conduction and convection, contributes to increased comfort and energy efficiency in the home.